So let's get into the examples. We will do a couple of examples and then I'll explain to you the concept of cocked hat. So let's get going. Let me set up the questions, set up the video.
Sir, after the class, if you get extra time, sir, can you explain this how to find the exact GMT of meridian passage? In practical navigation, the process is given, sir, but if you will explain once, then it will be more better.
Okay, beta, we'll do that. Don't worry. So we had one intercept position line and then later on the vessel steered a particular course and distance. There was some current also. We used this day's work table, found out the transferred position and then made the plot. This was the last which we did. Now moving on to the next one.
We take one more question. At 0830 hours in DR 48 degrees 30 minutes north, 024 degrees 20 minutes west, an observation of sun gave an intercept of 4 minutes towards an azimuth of 3 minutes away. Required ship's position both at 11:30 hours as well as at noon. Now, first we'll draw a rough diagram to figure out what is to be transferred and then mathematically calculate the transferred position.
Beta, you can give a reading to the question and just share with me if you have any doubts.
Sir, I have doubt in that second part of the question.
Which part, beta?
So after that, later at 11:30 hours, having run up DR position, that one.
Okay, so basically what is the meaning of having run up the DR position, right?
Yes, sir.
Right, beta. I'll explain that. So let's see that.
So let's first draw the DR at 8:30 hours. We draw the first PL. So this is the azimuth. We mark off the intercept towards the azimuth. That becomes the ITP. We draw the first PL here. So we get the first PL, which is perpendicular to this azimuth. So direction of the PL is 010 degrees to 190 degrees true. Now, before you apply run, please go back to the question. It says second observation, that is 11:30 observation, which is also an intercept observation, has been solved by using a DR, 11:30 DR, which was obtained by running up the earlier DR, that means 8:30 DR. So that means in this case, if I run up the ITP, yes, I can transfer the first PL, but then unless I have the 11:30 DR, I'll not be able to plot the second PL. So in this question, what makes better sense is that we transfer the 8:30 DR, and through the transferred DR, with respect to transferred DR, that 11:30 DR, we plot the first PL transferred and also the second PL out there. So please pay attention to the question. If the question said that the second observation has been solved by using the position obtained by running up the ITP, then we would have applied the run on the ITP and run up the ITP. But in this case, it says it has been obtained by running up the DR. So what do? We run up the DR.
So beta, I hope this is clear now.
Yes, sir.
Very good, beta.
We apply the CTS for 3 hours. The distance becomes 42 miles. We apply, and this position is the DR at 11:30. Now, with respect to this DR at 11:30, we can plot the first PL transfer with same azimuth, intercept, and direction of the PL. So we get the first PL transferred here. We can draw the second PL with respect to this DR. azimuth 175, intercept away, and we have perpendicular to the azimuth. This is the second PL. Obviously, this point becomes the fix at 1130. That means in this case, mathematically, what should we be interested in? We should be interested in finding the latitude and longitude of 1130 dr.
So beta, is the rough diagram clear? Any doubts in this? Very good, beta. So I hope it is clear. Let's move ahead then.
Thanks.
So we can apply plane and parallel sailing. Obviously, this diagram was not to scale. So we have this column out here. We have only one leg out here. That is the ship's own steaming. We get the DLAT as 14.4 minutes south and departure as 39.5 minutes west. We apply this DLAT to the latitude of 830 dr and we get latitude of 1130 dr as 48 degrees 15.6 minutes north. Then we find the MLAT between 830 latitude and 1130 latitude. We use this latitude to convert this departure of 39.5 minutes into D long. Apply this D long to the longitude of 830 dr, and once we apply this to 830 dr, we can get the longitude of 1130, and this gives us the position of 1130 dr, which can be used, as you can see in this rough diagram, to plot both the 1130 PLs, one transferred PL, other observed PL.
So you see beta, we have done the calculation part. We have obtained the DR for 1130 and now we are ready to go into plotting. So any doubts up to here?
Sir, I have one doubt, sir.
बोलो बेटा.
सर ये जो ट्रांसफर पीएल है ना सर, तो वो हम लोग डीआर पे ट्रांसफर नहीं करेंगे सर, मतलब वो डीआर
नहीं बेटा, because no we will not transfer it to the DR because बेटा उसमें इंटरसेप्ट भी था ना, हमने तो DR पे रन लगाया है. अगर हमने ITP पे रन लगाया होता तो जो पॉइंट हमारे पास आता हम वहां से ही इसे ड्रॉ कर देते. But since we have applied the run on the DR position, we have to apply the intercept by drawing, by plotting.
ओके सर, समझ गए.
सर एक डाउट रहता है हमेशा, जब अगर रन आईटीपी से लगाना हो तो सर हमको डीआर से आईटी पे जाना होता है ना सर?
That's right बेटा.
सर इस केस में अगर हमको आईटी से रन लगाना तो डीआर से वी गो टुवर्ड्स अजीमुथ, सेम फोर्स एज अजीमुथ कोर्स ना सर?
That's right बेटा. अगर इस क्वेश्चन में, that is if, अगर इस क्वेश्चन में हमें ITP पे रन लगाना होता तो हमारा पहला कोर्स होता DR to ITP. The course would be 100 and the distance would be 4 miles towards.
Yes sir, basically हमको DR से ITP जाना होता है, not ITP to DR, right sir?
That's right बेटा, that's right.
अगर अजीमुथ सर सेम क्वेश्चन में अगर अवे होता then we to go reverse course of 1800, right sir?
Reciprocal azimuth बेटा, right.
Okay sir. कार्तिक क्या?
हाँ जी clear. Sir, one more doubt, sir. कुछ questions में क्या होता है, they don't mention exactly कि ITP से लगाना है या DR से लगाना है. In that case, how to go about it?
Beta, just get that question, pick up that question. After we finish off these examples, we'll discuss. Let me see what is given in the question, then only we'll be able to judge. Okay. Usually it will be mentioned whether there will be some indication whether the run has been applied to DR or ITP. So if you get a question जिसमें कुछ भी mention नहीं है, just show it to me. I'll try to see what he wants. Okay, beta. Let's move ahead now.
Now, having got the 1130 dr coordinates, the two PLs can be plotted. We know the transferred PL shall have a direction of 010 degrees to 190 degrees true, and its ITP shall be basis this azimuth and intercept out here. And likewise 1130 PL we'll get the ITP using azimuth of 175 degrees true, intercept 3 miles away, and direction of the PL shall be perpendicular to azimuth, which comes to 085 degrees to 265 degrees true. So we can get going with the plot. You can see on your screens the DR position being identified. This is the latitude of DR, this is the longitude of DR. So let's first plot the transferred PL. We take a scale of 1 centimeter representing 1 mile. This is the azimuth of the transferred PL. We mark off this intercept, which is 4 miles towards. This becomes the ITP, and through the ITP we draw the transferred PL represented by 2 arrows at each end. Then we mark off azimuth for the 1130 PL 175. This is the 175 azimuth, and we have the intercept in the away direction 3 miles. We mark off the intercept here. This is the ITP. Then we draw the second PL marked with single arrows. Why? Because that's a celestial PL, observed PL, and not a transferred PL. Therefore this becomes the fix at 1130. Now we can measure its dlat from dr lat. We can measure the departure from dr long, convert the departure into d long, and apply it to the longitude of the dr, and we can get the coordinates. You can see dlat is measured off using this scale, comes to 3.4 minutes north. So is the departure, which comes to 4.7 minutes east. And then from the plot we can apply these and get the position at 1130. 1130 fixed latitude then comes to 48 degrees 19 minutes north. Departure can be converted to d long, applied to the longitude of 1130 dr, and that gives us the longitude of the fix as 25 degrees 12.4 minutes west. So this way we are able to get the coordinates of the vessel's position at 1130 hours.
So we completed the plot. Have a look, beta. Let me know any doubts coming in.
Sir, just 1 minute.
Okay, holding.
Excuse me, sir.
बोलो बेटा.
सर यहाँ कॉस्ट लैट की जगह एम लैट भी यूज कर सकते हैं ना?
बेटा mlat ही यूज
निकालने
किया है. If you look at the value, you see it is mlat only.
Okay, sorry.
Right, 4815.6 and the fixed lat is 4819. So they have used the mlat. Let me know once you are done, beta.
Yes, sir. Yes, sir.
Okay, beta. Great. So let's proceed ahead then.
Now from 11:30 fix, we can get the noon fix by applying the run for half an hour. And we can mathematically do it. We have the 11:30 fix whose coordinates we have just calculated. Now for half an hour, we apply the run. The vessel's course is 250 degrees true. In half an hour, the distance shall be 7 miles. We get the corresponding DLAT and departure. This DLAT can be applied to the latitude of 11:30 fix, and that will give us the noon lat. Using the MLAT between 11:30 lat and 1200 lat, we can convert this departure into D long, apply that D long to the longitude of 11:30 fix, and that gives us the noon longitude as 025 degrees 22.3 minutes west, and hence we get the coordinates of the vessel's position at noon on that particular day, and that's how this question can be completed.
So you see beta, in the question they had asked us the position at 11:30 as well as at noon. So 11:30 was obtained from the plot. For half an hour we applied the run using plane and parallel sailing, and we got the known position.
Just to summarize and to draw your attention, please be careful on taking a call as to which point needs to be transferred.
So moving on to the next question now beta.
After 1 minute, can be.
Okay.
स्क्रीनशॉट ले ले.
Okay beta, great. So let's see one more question now.
Be careful on taking a call as to which point needs to be transferred. Now we have a question which involves transfer of position circle. At 11:03 hours, an observer on a vessel steering 336 degrees true at 14 knots found the sun altitude to be 89 degrees 29.2 minutes, bearing southeasterly. Declination of the sun is given, GHA of the sun is given. Later, at 13:12 hours, a point of land whose position is given in the question was detected by radar at a range of 23 miles. Find the vessel's position at the time of second observation. Now, before we start with the question, I'm sure all of us would agree from our knowledge that at 11:03, it's a high altitude celestial observation. So we get a position circle with GP of the sun as the center and TZD as the radius. At 13:12, we again get another position circle with the point of land as the center and radar range as the radius.
So I hope beta the question is clear. Any doubt in question, please share with me. Go ahead beta.
सर ये जो क्वेश्चन को एक्सप्लेन किया है सर, एक बार फिर से 1 मिनट रिवाइज कर देंगे.
Okay beta, if you have a look, the first observation 11:03, the altitude of the sun is 8929.2. So you can see this is a high altitude observation. A high altitude observation is plotted using a position circle concept. Center of the circle is the GP, which is obtained from declination and GHA. Radius is the true zenith distance. Now the second observation, if you see, it is also a position circle. We have a point of land and we have a radar range. So both are position circles, different times. We have to transfer them to the same time and get the fix. Right, beta?
Yes, sir.
Great. Let's see that now.
Now, since we have two position circles separated by a certain interval, we need to run up the first position circle, and to do so, we'll have to transfer nothing else but only the center of the first circle. We do not have a choice when it comes to transferring position circles. It is the center and only the center that needs to be transferred. So We have the 1103 PC. That 1103 PC shall be drawn with the center as the sun's GP. What will be the GP of the sun? Latitude shall be equal to the declination and longitude shall depend on GHA. Here the GHA is more than 180. So the longitude will be, because longitude cannot be more than 180, it shall be 360 minus GHA, and this time the longitude shall be easterly. So we get the coordinates of the GP, and that becomes the center of 1103 PC. Radius of 1103 PC shall be equal to TZD. True altitude is given as 89 degrees 29.2 minutes, which gives us the TZD or the radius as 30.8 miles. Now we run up this center. Which center? Whose latitude is 13 degrees 26 minutes south and longitude is 055 degrees 08.8 minutes east. We run it up from 1103 to 1312. During this interval, the vessel shall be doing a course of 336 degrees true, and at 14 knots, the vessel shall be covering a distance of 30.1 miles. Now, this part of it I have not shown on the screen, but I have calculated it. You can also calculate, just to save on time. I'm assuming that you'll be able to calculate the coordinates of the transferred center, 1103 center, which is transferred, applying this run using plane and parallel sailing. We get the 1103 PC transferred to 1312, center of that rather. The center comes to 12 degrees 58.8 minutes south and 054 degrees 56.4 minutes east. Please do this calculation and see that you're comfortable and you are able to get this as the center of the transferred PC. The radius obviously shall remain the same as the original PC, which will be 30.8 minutes. Now 1312 PC, which is by radar range, will have its center as the point on land, whose lat and long is given in the question, and the radius shall be 23 miles. Now, having transferred the center of the first PC, now we can draw two position circles for the same time. One position circle shall be the transferred position circle. The first position circle transferred to 1312 with the center in 12 degrees 58.8 minutes south, 054 degrees 56.4 minutes east, and radius of 30.8 minutes or miles. The second position circle will be observed position circle for 1312 with center as the point on land and radius as the radar range of 23 miles.
So you see, beta, the calculation part is done. We have the coordinates of both the circles. So we will be going into plotting now. Any doubts up to here?
Sir, the explanation I'm not getting, sir. Can you explain from your side, sir? It's better. From your perspective, sir. Please.
Is there any part, beta, where you are getting doubt or कुछ भी समझ में नहीं आया?
No, sir. I'm still confusing, sir. So I like from your side, sir. So I think I will understand more.
Okay, but can you
And
give me
your
any indication
perspective.
जहाँ पे doubt आ रहा है बेटा? Any indication जहाँ पे doubt आ रहा है जो समझ में नहीं आ रहा है?
Sir, from it is starting from this point for transferred PC from in left side.
Okay, beta. All right. You see,
Okay,
at
thank you, sir.
1103, we obtained a high altitude observation. High altitude observation gives us a position circle. Agree?
Yes, sir.
We obtained the center of that circle. The center came to be 1326 south, 05508.8 east, and radius came out to be 30.8 miles. This is for 1103, correct, beta?
Yes, sir.
Now from 1103 to 1312, vessel has moved on a course of 336 at a speed of 14 knots. So if we want to transfer this position circle, we have to apply our course and distance to the center of the PC, right?
Yes, sir.
Okay. So we have a course of 336 and the distance covered from 1103 to 1312 with a speed of 14 knots is 30.1 miles. So this is the course and distance which we have to apply to transfer the PC. So we apply this course and distance to the center of our 1103 PC using plane and parallel sailing, and we get the center of the transferred position circle, which is 1258.8 south, 05456.4 east. So now you know how this is obtained?
Yes, sir, I got it now.
Very good, beta. On the right hand side, you see the top box. It shows you the same details for transferred position circle, correct?
1312. Yes, sir.
It has been now transferred to 1312. Okay. Now
Yeah.
at 1312, we have a point of land whose radar range is known to us. So we can also draw a PC using this. We have the point of land coordinates. Just a minute, beta. Just give me 1 minute.
कैप्टन साहब का कॉल आ रहा है. भाई लोग एक बात बताओ यार, ये स्टार के केस में सीएमटी मेरिडियन पैसेज कैसे निकालते हैं यार?
बेटा थोड़ा रुक जाओ, फिर बताएंगे. अभी पहले इसको चलते हैं आगे, मैं बता दूंगा, डोंट वरी.
अरे सर आप फोन पे देना तो मैं बाकी दोस्तों
वो
से पूछ रहा था.
खत्म हो गया बेटा. सो यू सी बेटा, पहला पीसी हमारे पास आ गया टॉप राइट कॉर्नर, एंड जो सेकंड पॉइंट ऑफ लैंड पे पीसी हमने ऑब्जर्व किया है, वी हैव द रेंज, वी हैव द कोऑर्डिनेट्स, वो हमारे पास आ गया. अब इन दोनों को हमने प्लॉट करना है. सो इज इट ओके नाउ? यू आर क्लियर?
Yes, sir. Sir, one more thing, sir. How can you explain about the longitude, sir? How it come east?
Okay, beta, did you understand the high altitude observation in chart work?
Yes, sir. Yes, sir. I just have confusion about that east. How it became.
No problem.
I understand the system. Yeah.
I'll tell you, don't worry. Whenever the GHA of the body is less than 180, longitude is equal to GHA and is named west. Correct, beta?
Yeah, okay. I got it, sir. Now, okay. Now, in other words, it is.
Yeah, that's right. Whenever the GHA is more than 180, longitude is equal to 360 minus GHA and it is named east.
Okay, got it.
Okay, great. So we have the coordinates, we have the information for plotting the position circles. Let's plot them now.
So we have the 1312 transferred PC, whose center we are calling as X, whose coordinates are 12 degrees 58.8 minutes south and 54 degrees 56.4 minutes east, and the radius of the PC shall be 30.8 miles or minutes. And 1312 PC, which is an observed position circle, we are calling it center as Y. Coordinates of Y and radius of the PC are there on the screen. Now the DLAT from X to Y, X is the center of transferred PC, Y is the center of the observed PC. DLAT between their centers happens to be 40.8 minutes north. That means Y is 40.8 minutes north of X, and D long between the two happens to be 11.4 minutes west, and M lat between the two is 12 degrees 38.4 minutes south. Using this M lat, this D long can be converted into departure from X to Y, and the departure comes to 11.1 minute west. Now with this information, we can get going with the plotting. First we have this latitude of X, that is the center of the transferred position circle. We have the longitude of X. Obviously this point is the point X, and what is point X? It is the center of the transferred PC. Now using a suitable scale we have taken is 1 centimeter representing 5 miles, because distances involved are slightly larger, like 23 miles and 30 miles, and therefore the scale is 1 centimeter is to 5 miles. Using this scale, we can mark off the D lat and get the latitude of the point Y. So we mark off this D lat using this scale. The D lat you can see here, the D lat was 40.8 minutes north. We mark off that D lat and we get this is the latitude of point Y. Likewise, we can mark off the departure from X to Y and get the longitude of point Y, and obviously then where it intersects here is the point Y, and this point Y is going to be the center of the position circle, which is by radar range. So what we have done, we have plotted point X and Y. Now with point X as center and radius of 30.8 miles, using the scale of 1 centimeter equal to 5 miles, we draw the transferred position circle, and this one is the transferred position circle which has come on the screen. Likewise, with Y as center and radius of 23 miles, using the same scale, we draw the 1312 observed position circle. This is the 1312 position circle, and this is the 1312 transferred position circle. These two position circles are intersecting at this point here, which we can call as A, and it's also intersecting at this point, which we can call as B. That means in this case, the vessel could be either at position A or position B. Now, if you go back to the question, it says the sun was bearing southeasterly. Now, obviously, the sun's position in this case will be represented by its GP, which is getting transferred to X. So obviously, if the sun was bearing southeasterly, the vessel has to be at point A for the sun to bear southeasterly. Therefore, in this case, position B gets ruled out, and the vessel's position happens to be then point A. Now we can measure its D lat from one of the reference latitudes, also the departure using the same scale as the scale for the plot. We get the D lat from latitude of X as 21 minutes north, and we get departure from longitude of Y as 13.3 minutes west. We can use plane and parallel sailing formula and use the coordinates of the reference points from where the measurement of D lat and departure has been done, and we can then apply them here, and we end up getting, when we convert the departure into D long and we apply, you can see the working on the screen, and it eventually gives us the fix at 1312 as 12 degrees 37.8 minutes south and 54 degrees 31.4 minutes east. So here we had two position circles. We transferred one of the position circles. You could have a situation in which you could have one position circle and one position line. So the combination could be two PLs, two PCs, or one PL and one PC.
Okay, beta. So that completes the solution. So let me know any doubts coming in the plot, in the working, anywhere.
Sir, can we do this question in a different way? Let's
tell me, beta.
At 11:03. The sun to altitude is given, so we will get mean zenith distance and ZD. And since the bearing of the sun is also given as the westward, which is southeasterly, right?
You're right.
So we draw PC first, position circle, and we draw the sun bearing, which is southeasterly. Wherever it cuts it, we will get 1103 fix for that time. From there, we can run the course, which is 336 in this case, and meantime, from the initial GP, for the GP position of the sun, we will draw this land position and draw 23, whatever it is, 23 miles of circle around position circle, and wherever the course cuts it, that will be the position.
Okay, beta. Now, beta, what you have used is you have used the altitude of the sun and the bearing.
Yes,
correct.
Sir. MZT and bearing, yes.
Beta, how can you say that this is the MZD, meridional zenith distance? How can you say it was the meridian passage of the sun at 1103? Is there anything mentioned in the question?
What it looks like. No, sir, I'm not saying that. Just we were using, right, true zenith distance or MZD, 90 minus whatever it is for a position circle. Same way we can draw position circle and draw the sun azimuth. That will give us 1103 fix.
Okay, got it. So you are basically drawing the position circle and marking the southeasterly bearing to get the position of the vessel, right?
Correct, sir.
Okay, that is not principally done in navigation, beta, because if we do that, we will straight away get a fix. We don't even need the second position circle in that case. To that fix, if you apply,
yeah. The position circle, what is the need? Because I got we have one question like that.
I got it, beta. I got. Let me explain. Let me explain. So if you get that fix in that way, you can apply the run and get the second fix also. So second position circle is not required in that case. But we don't do this in navigation. The reason being, beta, this bearing which is given to us is a southeasterly bearing. It is not a perfect bearing. You see, when we take the bearing or we calculate using the ABC method, our minimum resolution is 0.1. When you practically take it on board using a azimuth circle, the maximum accuracy which you can get is half a degree. Now this 0.1 error in the bearing or the azimuth of the sun can lead to very great errors in the positions. Because you see the sun is so far away. If you take even 0.1 minute of error in its bearing, the position circle or the PL is going to go miles away. So this method is not used in navigation. So we do not use the azimuth of the body to draw a PL. So that's why we cannot use this beta. Okay, beta, got it?
Yes.
Right. Otherwise you were thinking on the right lines. So, but we don't use it. Principally, we don't use it in navigation.
Sir, can you question का जो last part है where we had ruled out the position B. मैं सर प्लॉट में एक्चुअली वो विजुलाइज नहीं कर पा रहा हूँ कि हम किस तरह से हम B को हमने वो कर दिया रूल आउट.
ओके बेटा, अभी समझा रहा हूँ आपको. मुझे ये बताओ कि दो सर्कल हमें दिखाई दे रहे हैं, एक ऊपर एक नीचे. इनमें से ट्रांसफर्ड सर्कल कौन सा है?
ट्रांसफर्ड सर्कल सर नीचे वाला है.
वेरी गुड. और ये जो ट्रांसफर्ड सर्कल है ये सन की ऑब्जर्वेशन से आया था 8929.2.
यस सर.
एंड इस सर्कल के सेंटर में सन की जीपी है, ज्योग्राफिकल पोजीशन.
यस सर.
सो दैट मींस द जीपी ऑफ द सन इज एट पॉइंट एक्स.
Okay.
Right? Okay, if you are at point Bravo, if the ship is at point Bravo, what will be the bearing of X?
It will be somewhere southwesterly, somewhere. Right. And we had to keep it southeasterly, so we had ruled out B. Okay, got it, sir.
Very good, बेटा. और बताओ बेटा, और क्या डाउट आ रहा है? Okay, beta. Great. Excellent. So this is also understood. So shall we move on to cocked hat concept now?
Yes, sir.
Yes.
Great, beta. So I'm moving on to the cocked hat now. Triangle. This triangle is known as a celestial cocked hat. Now, when we are resolving a celestial cocked hat, the first important point to be clear in our mind is the same one, and that is that in case the error in the three position lines is different, then it cannot be resolved. The foremost condition for resolution of a cocked hat is that the error in the three position lines should be similar, of same sign and same magnitude. If the error in all the three PLs is similar, then the cocked hat can be resolved. Now, for resolving the cocked hat, the first thing which we need to check is that whether the three bearings are contained within 180 degrees or not. Now, what does this step mean? Let me explain to you. Now, how do we find out in a particular question whether the bearings are within 180 degrees or not? We can easily understand it using a simple example. Let's assume that we have a DR position in this particular location and we have obtained three celestial observations. Let's assume that the first observation was taken using the red colored star. It is identified as star 1 and is having a azimuth of 050 degrees. Let's mark the azimuth in the diagram. You can see the azimuth coming up. Let's assume that the second site was taken using this blue color star, star number 2, having a azimuth of 358 degrees. So you can see the azimuth of the second star also. Let's assume the third PL was obtained using the green color star, marked as star number 3, on an azimuth of 330. We are just assuming some values to understand the concept of how to identify whether bearings are within 180 or not. Now, once you have made this simple diagram, having the DR position and having the three celestial bodies and their azimuth, now you try to draw a straight line passing from the DR position so that all the three objects should come on one side of it. I repeat again, we try drawing a straight line which is passing from the DR position in such a way so that all the three objects come on one side of that line. If it is possible to draw that kind of a line, the bearings are said to be within 180 degrees. If it is not possible to draw such a line, the bearings are said to be not within 180 degrees, or you can also convey the bearings are stretching outside 180 degrees. Now let's try to see in our scenario, in our example, whether we can draw the line or not. Now in this case, you can easily draw a line lying in the east-west direction, east-west orientation. You can see this maroon line coming up on the screen. Now this line is passing from the DR position and all the three stars are on one side of that line. So since all of them are falling on one side of the line and it is possible, these bearings are within 180 degrees. So in this particular case, the bearings lie within 180 degrees.
Sir, the line must be passed through the DR position, right, sir? The straight line.
That's right, beta. That's right. It should pass from the DR position.
Okay.
3 point bearings से similar लग रहा है सर ये.
So can I ask one doubt?
बोलो बेटा.
This line which says bearings within 180 degrees, sir, it can be any angle from 0 to 360 degrees, right? It can be 10 to say 180 or 350 to 170, anything, right?
Anything, beta. Anything.
Oh, okay, perfect.
Sir, if this star azimuth 050 would have been 095, then?
Okay. If this was 095, you draw a line in the 095 azimuth and you draw the star there. And then you try to draw a line from the DR, any line, so that all three come on one side. You will still be able to draw it, so it will still remain within 180 degrees.
Yes, it should not be like east-west or something like that.
No, beta.
Sir, can you draw that what Santosh just said about 095 in case?
ओके बेटा, अभी कर देते हैं ड्रॉ. 1 मिनट दो मुझे. सो कौन सी बियरिंग चाहिए बेटा आपको?
Any above
095 चाहिए. ये लो बेटा. Can you see the star at 095?
Yes, sir.
Very good. So now the star is at 095. Can we draw a line from the DR so that all three stars come on one side of it? Can we draw it?
Yes, sir, we can draw it.
We can still draw it. So you can see, let me draw. You can draw a line like this, beta. You see, we are able to draw this line and all the three stars are on one side of it. So it is still within 180 degrees, right?
Yes, sir.
Sir, in case azimuth 145, sir?
Okay, बेटा उस केस में भी मेथड तो यही रहेगा. So just plot it on your notebook and then you see it. So you are saying 145, right?
Yes, sir.
Okay, 140. 145. Just a minute.
इसमें एक लाइन तो अपन वही ले सकते हैं ना.
ये लो बेटा, ये रहा 145 पे आ गया तुम्हारा स्टार यहाँ पे. It will be here. So still within 180 बेटा.
Sir.
Excuse me, sir.
170.
Sir, अगर
sir, can you give one example of not
reciprocal होगा तो सर?
बेटा ग्रेटर देन 180 की अभी देता हूँ एग्जांपल. पहले यहाँ डाउट क्लियर होने दो. हाँ, और कोई अजीमुत चाहिए बेटा, बताओ.
सर इसमें एक
180 degree line, then sir number 3 and number 1 is come on the straight line. Then what? Then we
will never
230 पे
170.
बेटा एक एक करके पूछो. 180 डिग्री पे कभी भी आपको दो स्टार नहीं मिलेंगे. नेवर यू विल गेट इट. Because if you get it, the question becomes very simple. So वो आपको कभी नहीं मिलेंगे बेटा. There will never be two stars at 180 degrees, right?
इसमें
230
तीनों
और क्या और
हाइड्रो वो स्टार एक तो स्टार पे ले सकते हैं. पे वो लाइन ले लिया बचेंगे ना फिर.
बेटा दोबारा से बोलिए आपका डाउट.
जैसे 180 से सारे एक साइड होने चाहिए, करेक्ट सर? एक लाइन के तीनों.
All the three stars should lie on one side of the line.
So if I draw line on one azimuth only, like either the extreme end, na, if either I draw on star 3 or star 1, so the remaining can be 2 only. So that is also possible.
You are right. That's right. बिल्कुल सही है.
ठीक है सर. Okay.
Okay. अब बेटा, before you ask further doubts, let me give you an example when the bearing stretches not within 180. Okay. So उसको देखने के बाद फिर आप बाकी के doubts भी पूछिए. Let's go to that example. Let's now try to see an example where the bearings do not lie within 180 degrees or they are stretching outside 180 degrees. We follow exactly the same procedure. We make a small diagram, rough diagram. First we plot the DR position. You can see the DR position coming up on the screen. Then we plot the three celestial bodies and their azimuth. We have the red star, which is star number 1 at an azimuth of 050. You can see the azimuth coming up on the screen. The second star which we used in this example is the blue colored star, star number 2 on an azimuth of 178 degrees. Let's mark the azimuth of the star. And the third star which we use for this particular example is the green colored star, marked as star number 3 on an azimuth of 330 degrees. You can see the azimuth of all the three stars coming up in the diagram. Now if you try to draw a straight line passing from the DR position, it is not possible to draw a line in such a way that all these three objects, all these three stars, star 1, star 2 and star 3, they lie on one side of the line. It is not possible to do that. Whichever line you draw from the DR position, you will see some of the stars will lie on one side of it and some of the star will lie on the other side of it. So in this particular case, it is not possible to draw a straight line passing from the DR position in such a way that all the three objects come on one side of it. So that tells us the bearings in this case are not contained within 180 degrees. They stretch out of 180 degrees. They are not contained within 180 degrees.
Yes, I got.
So I hope it is clear now.
Yes, sir.
Yes, sir. Can we see the first page of the presentation, sir, once again?
Okay, बेटा. ये लो बेटा, ये फर्स्ट पेज आ गया.
नहीं, इसके पहले वाला सर.
इसके पहले वाला ये रहा बेटा.
Sir, actually what Lokesh was saying was right, sir. In case of within 180 degrees, we can draw lines from the azimuth of extreme of the stars. This is star 1 and star 3. And then we can conclude also that whether it is in 180 or not.
Exactly बेटा, very good, you understood it.
Yeah, I mean Lokesh said it very easily.
सर ये if unknown error, इसमें error क्या होता है सर? If unknown errors of different signs और magnitude वाला?
Okay बेटा, so इसका meaning क्या है? If unknown error is of the same sign and magnitude, we have the cocked hat method resolving. इसका मतलब ये है बेटा कि ये जो cocked hat बनी है, आपने 3 साइड ली और ये तीनों एक पॉइंट पे नहीं कटी, ये तीनों एक ट्रायंगल बना रही हैं. ये तभी पॉसिबल होगा अगर आपकी साइड में कुछ एरर हो, अदरवाइज तो तीनों एक ही जगह पे कटनी चाहिए, राइट?
हाँ सर, साइड में एरर है.
तो इसका मतलब साइड में एरर है. अब दो पॉसिबिलिटीज हो सकती हैं. एक पॉसिबिलिटी तो ये हो सकती है कि एक साइड में एरर है, बाकी की दो करेक्ट है.
हाँ सर, हो सकता है.
दूसरी पॉसिबिलिटी ये हो सकती है कि तीनों की तीनों साइड में एक जैसी एरर आ गई. जैसे मान लो आपने हाइट ऑफ आई गलत लगा दी, तो वो तीनों में हाइट ऑफ आई गलत लगी, तीनों में एक जैसी एरर आ गई. दो पॉसिबिलिटीज हो सकती है ना?
हो सकती है सर.
कॉक्ड हैट का मेथड सिर्फ उसी केस में लगता है जहां पे तीनों पीएल में एक जैसी एरर हो. अगर अलग अलग एरर है तो फिर ये मेथड काम नहीं करेगा.
ओके सर, ठीक है.
वेरी गुड. सो अब मैं आगे चल रहा हूं बेटा. हमने देख लिया है विद इन 180 कब होता है और आउटसाइड 180 कब होता है. हमें पता चल गया है कि इसको कैसे आइडेंटिफाई करना है. अब मैं दोनों कंडीशंस में कॉक्ड हैट की रेजोल्यूशन कैसे होती है वो बता रहा हूं. तो आपने अबाउट अब थोड़ी देर के लिए ध्यान इधर रखना है. Okay, so this is little, sometime people say it is complicated. So just pay your attention here. Huh? So first we are going into bearings not contained within 180. So let us see that. Now, once we have identified whether the bearings are contained within 180 degrees or they are stretching outside 180 degrees, we can now start the procedure to resolve the cocked hat. So we are now going to see the first example in which the bearings are not contained within 180 degrees. So in our plot, first of all, we mark the DR position. There are three observations, and for this example, let us assume that all the three observations were taken using the intercept method. So you can see the first celestial body, the first star, red color star coming up on the screen. This was used to obtain our first PL. This is star number 1. Let's mark off the azimuth of star number 1. You see the azimuth coming up. Now let's assume the intercept was towards. If the intercept is towards, then from the DR position we go towards the star up to a distance equal to the intercept, and the point where we reach is the ITP, intercept terminal point. So you can see the ITP point coming up on the screen. The position line passes from the ITP and is perpendicular to the azimuth of the body. So we can now see the position line of the red star coming up on the screen. The first position line is plotted. Let's assume that the second star which we used was the blue star in this location. This is star number 2. Let's mark the azimuth of the star. And let's assume that in this case also the intercept was towards. So from the DR position we go towards the star equal to a distance which is equal to the intercept obtained, and we reach up to the ITP, intercept terminal point. You can see the ITP coming up. The position line will be passing from the ITP and will be perpendicular to the azimuth of the star. So let's mark the PL. You can see the number 2 PL, the blue color PL coming up. It is passing from the ITP and it is perpendicular to the azimuth of the star. This is position line number 2. Now let's mark the third celestial body. You can see the green star coming up. Let's mark the azimuth of the star. Now this star site was also worked out using the intercept method, and let's assume the intercept was towards in this case too. So from the DR position I go a distance equal to the intercept towards the star and I reach up to the ITP, intercept terminal point. ITP point is marked and the PL passes through the ITP and is perpendicular to the azimuth of the body. So we have all the three position lines on the screen now: red color PL, blue color PL and the green color PL, not intersecting at a single point but instead making a triangle. So this is a cocked hat. Now if you look carefully, the bearings of all the three stars are not contained within 180 degrees. Because it is not possible to draw a line from the DR in such a way that all three of them come on one side of it. It is not possible to do that. The bearings are not contained within 180 degrees. Now how do we resolve this cocked hat? Now for resolution of the cocked hat, you see this triangle which is being formed has three vertices. Let's name the topmost vertex as A. Now this angle of the triangle which is being made, represented by this blue color arc, we have to bisect this angle, or we have to draw the angle bisector of this particular angle. The second vertex where the red and blue lines intersect is marked as Bravo, and the third vertex is marked as Charlie. So as mentioned earlier, we now have to draw the angle bisector. So we draw the angle bisector of angle A. You can see the dotted line. It is the angle bisector of angle A. It divides angle A into two equal parts. The dotted line shows the angle bisector. Now similarly, we draw the angle bisector for angle B. You can see the angle bisector for angle P also coming up. And likewise, you draw the angle bisector of angle C. You can now see the angle bisector of angle C also coming up. All these three angle bisectors should intersect at a single point. This is a geometry principle that all the three angle bisectors of a triangle intersect at a single point. And this point where the angle bisectors intersect is the fix of the ship. So you can see the fix symbol coming up. We have a circle and also signified as fix. So this is how we resolve the cocked hat when the bearings are not contained within 180 degrees. So very simple method. Draw the three position lines, have the cocked hat or the triangle on your plot, draw the angle bisector of all the three angles of the triangle, and wherever these intersect, that point is the fix of the ship. So beta, any doubts?
Sir, this bisector is actually a straight line, sir, from that central point.
Beta,
Can you explain how to draw bisector?
Bisector is a line which divides the angle into equal parts. If this angle A is 60 degrees, you have to draw a line which makes 30 degrees to either side of this angle. This is angle bisector.
Oh, okay, sir.
Sir, we can use protractor.
You should use protractor, beta. Protractor is the easiest and the quickest method to draw a angle bisector. Please use a protractor or a D or a 360 degree round to measure this angle and draw the bisector.
Okay, sir. सर एक मेथड और कंपास से करते हैं कुछ लोग, सर वो कैसे करते हैं?
बेटा भूल जाओ, और मेथड बिल्कुल दिमाग से बाहर निकाल दो, बिल्कुल भूल जाओ।
उसमें वो प्रोटेक्ट वाला भी बता दो, सर कट लग जाएंगे सर कि कंफ्यूजन हो जाएगा। आई नो दैट।
भूल जाओ बेटा, भूल जाओ। मुझे पता है कितने मेथड है, मैं नहीं बता रहा हूँ आपको, नहीं करने हैं वो। एक्यूरेसी कम है, हौच पौच हो जाएगा आपका प्लॉट, टाइम ज्यादा लगेगा, कोई बेनिफिट नहीं है। सो जस्ट यूज ए सिंपल प्रोट्रैक्टर एंड ड्रॉ द एंगल बाइसेक्टर्स। और डाउट बताओ बेटा।
सर ये कॉकहेट हमेशा इंटरसेप्ट और साइमल्टेनियस ऑब्जर्वेशन में ही एप्लीकेबल है क्या?
नहीं बेटा, ये किसी भी तरीके से बन सकता है। ये अलग अलग मेथड से भी बन सकता है। एक पीएल इंटरसेप्ट की हो, दूसरी लॉन्ग माइक्रोन की हो, तीसरी पोलारिस की हो, उससे भी ये बन सकता है। आपको कोई टेंशन नहीं लेनी है कि किस मेथड से बना है। आपको तो तीनों पीएल्स को प्लॉट कर देना है। हमें पीएल को प्लॉट करना आता है। जब ये ट्राइंगल हमारे सामने आएगी तो हम इसे सॉल्व कर देंगे। सो एनी मेथड कैन बी देयर इन ए कॉक्ड हैट क्वेश्चन, राइट?
ओके सर, यस सर, ओके।
और बताओ बेटा, और डाउट्स?
डाउट है कि ये जो बेयरिंग ले रहे हैं विद इन 180 डिग्री, तो ये सर इसका बेस कहाँ से लेते हैं? नॉर्मली कहाँ से उसका बेस लेंगे, so that we come to know this is 180 डिग्री से ज्यादा है या कम है?
बेटा आप मुझे ये बताओ कि जब आपको 3 साइड दी होंगी तो आप ये तीनों स्टार की पोजीशन को अपने नोटबुक पे ड्रॉ कर लोगे बेटा, डी के साथ?
यस सर, ओके सर।
कर लिया आपने ड्रॉ करने के बाद बस एक ही चीज देखनी है कि डी आर पोजीशन से ऐसी लाइन ड्रॉ कर सकते हैं ताकि ये तीनों उसके एक तरफ आ जाएं या नहीं। ओके, 1 मिनट 2 मिनट उस पे लगाओ, देखो ऐसी कोई लाइन बनती है।
मतलब डीआर के सेंटर से।
बेटा DR पोजीशन से ही लेनी है लाइन। क्लियर बेटा, निकाल लोगे अब?
Sir, one doubt.
बोलो जी।
The compulsory is not that the all three angles have to be same, right? Can be different also, right?
Yes बेटा, very much angles can be of any value. जरूरी नहीं है कि एंगल सेम हो, they can be different.
Okay.
ओके, सो अगर बेटा इस पे कंफर्टेबल हो तो लेस देन 180 वाला भी देख लें।
Yes, sir.
वेरी
Yes,
गुड
sir.
बेटा। इफ यू वांट यू कैन टेक ए स्क्रीनशॉट। ये डायग्राम इतना क्लियर आपको नहीं मिलेगा और कहीं, सो यू कैन टेक ए स्क्रीनशॉट एंड कीप इट विद यू। So we will now move on to bearings contained within 180 degrees case. So moving on to the second case now beta. Let's now move on to the second scenario where the bearings are contained within 180 degrees. Let me show you an example. Let's assume that we have the DR position at this particular location. You can see the DR latitude and longitude coming up on the screen. Let's assume that this was the first star which we used for our site. This is star number 1. The site was worked using intercept and we obtained the intercept towards this body. So let's mark the azimuth of this star. You see the azimuth coming up. The intercept is towards, so from the DR position we go towards the body a distance equal to the intercept, and the point where we reach is the ITP, intercept terminal point. We know that the position line will pass from the ITP and it will be perpendicular to the azimuth of the body. So you can see the first position line coming up on the screen. The red position line is there in our plot. Let's assume the second star which we used for our site was this blue color star, star number 2. And in this case, the intercept which was obtained was away. So let's first mark the azimuth of the star. You see the azimuth coming up. The intercept is away. So from the DR position, we move away from the body a distance equal to the intercept and we reach at the ITP. Once the ITP is there, we can now plot the second PL. You can see the blue color position line number 2 coming up in our plot. Let's assume the third site which we had taken is by using this green color star, star number 3, again worked out with intercept, and the intercept is towards in this case also. So from the DR position we go towards the body a distance equal to the magnitude of the intercept. We reach at the ITP, intercept terminal point. Passing from the ITP is our PL and it is perpendicular to the azimuth. So we have all the three position lines now in our plot. Red, blue and green position lines. And these position lines are not intersecting at a single point, but instead making a cogged hat, making a triangle. And we have the cogged hat now in our plot. Now you can easily see in this diagram that the bearing is contained within 180 degree. The bearing stretch of the three stars is contained within 180 degrees. How can we check that? Very easy to do. The method was to draw a line from the DR position in such a way that all the three celestial bodies fall on one side of that line. And here we can see that if we draw a line in the east-west orientation, passing from the DR position, a line in the east-west orientation, then all these three stars red star, star number 1, blue star, star number 2, and green star, star number 3 will fall on one side of that line. And when that happens, it means that the bearings are contained within 180 degrees. So in this case, the bearings are contained within 180 degrees. So up to here is clear, beta? Any doubt?
Sir, just one small thing. Here in the second star you drew intercept away. वही अभी towards वो भी रहता तो ऊपर बनता ना.
That's right बेटा. PL थोड़ी ऊपर चली जाती, ट्रायंगल थोड़ी सी छोटी हो जाती, अदरवाइज तो सेम ही रहता बेटा.
Correct. Okay.
What
Right.
if star 3 intercept is away?
अगर वो भी अवे होता तो ग्रीन लाइन बेटा और थोड़ा दूर आ जाती, ट्रायंगल छोटी बन जाती. Rest everything would remain the same. Right?
Yes, sir. Got it.
वेरी गुड बेटा. बस अब बेटा 2-3 मिनट आप ना आप ध्यान देना, मैं आपको स्टेप बाय स्टेप बताऊंगा इसको कैसे रिजॉल्व करना है. सो जस्ट पे अटेंशन फॉर 2-3 मिनट्स. डोंट मिस दिस, अदरवाइज कंफ्यूजिंग रहेगा बाद में. सो पे अटेंशन. लेट्स गो. Now whenever we have such a scenario where the bearings are contained within 180 degrees, we will always be able to identify one particular star which lies in between the other two stars. Like in this example, we see the red color star, the blue star, and the green star. Now if you look at the stretch of the bearings, you will be able to understand that the red color star is at one extremity, at one end of the stretch. The green color star is at another end of the stretch, and this blue color star lies in between star number 1 and star number 3. This star is known as the middle star. So I repeat once again. Whenever the bearings are contained within 180 degrees, you will be able to identify one particular star which lies in between the other two stars. In this case, in this example which we have taken, the blue color star lies in between the red star and the green color star. So the blue color star is our middle star. Now once the middle star is identified, the next thing which we do is to identify the position line associated with the middle star. So we can see the position line number 2, the blue color position line, is the one which is associated with our middle star. This PL, the blue color PL, position line number 2, is specified as the middle PL, middle position line. Now once we have identified the middle PL, in our case the blue color PL, you will see that this middle PL is involved in making two angles of the triangle. Let us name the vertices of the triangle. This vertex, let's name it as A. The second vertex where the red and blue lines intersect, let's name that as B, Bravo. And the third vertex where blue and green lines intersect, let's name that as Charlie. So we have the three vertices of the triangle, Alpha, Bravo, and Charlie. Now you will be able to see that our middle PL, that is the blue color PL, is involved in making two vertices or two angles of the triangle. These angles are angle Bravo and angle Charlie. Angle alpha is not associated with our middle PL in any way. Angle Bravo and angle Charlie have the middle PL as one of their arms. So we have to identify the two angles which are connected with our middle position line. In our case, angle Bravo and angle Charlie are connected with the middle PL, which is the blue color PL. Now for these two angles which we have identified, Bravo and Charlie, we have to draw the external angle bisectors. Now what do we mean by external angle bisectors? Let me show you in the diagram. We have identified the middle star, the blue color star, and its associated PL, the blue PL. We have identified the angles which are involved with the middle PL, in our case angle Bravo and angle Charlie. And now we are going to draw the external angle bisectors for these angles. Now this angle which you see in the diagram now, which has come up in the diagram, this is known as the external angle Bravo. It is outside the triangle and it is called as external angle Bravo. Now in the case where the bearing stretch was greater than 180 degrees, we drew the internal angle bisector. You see, this was the internal angle, and we had drawn the angle bisector of the internal angle which lies inside the triangle. But now in this case, we are going to draw the angle bisector of the external angle bisector. So let's draw the angle bisector now. You see the dotted line coming up as the external angle bisector. This is going to divide this angle into two equal parts. So we have the external angle bisector for angle Bravo in our plot. Now we do the same thing with angle Charlie, angle C. We draw the external angle C. You see the external angle Charlie coming up in the plot. And we draw the angle bisector for this external angle. So you can see the external angle bisector coming up. This also divides angle Charlie, external angle Charlie, into two equal parts. So we have drawn two angle bisectors for Bravo and Charlie. Now for the third vertex, that is alpha, we draw the internal angle bisector as usual. So let's draw the internal angle bisector A. You have the internal angle coming up in the plot, and we now draw its internal angle bisector. You see the dotted line internal angle bisector of A coming up, and you will see that all these three angle bisectors will intersect at a single point. Now this is also a geometry principle. The external angle bisectors of two angles and the internal angle bisector of the third will also intersect at a single point, and this point is our fix in this particular case. So you see the circle coming up, that is the symbol of the fix, and you see it written as the fix in the plot. So this is how we resolve the cocked hat when the bearings are contained within 180 degrees. Important thing to see here is that the fix in this case will always be outside the triangle or outside the cocked hat. In the case first scenario where the bearings were not contained within 180, the fix was inside the triangle or inside the cocked hat. But in this particular case where the bearings are contained within 180 degrees, the fix of the ship will be outside the cocked hat or outside the triangle, and it will always be towards the direction of the middle position line. Our middle position line was the blue PL. So you will see the fix will always be on the side outside the triangle towards the side of the middle PL, middle position line. So with this we complete the resolution of the cocked hat in the scenario when the bearings are contained within 180 degrees. So now you can go ahead with your doubts, beta, one by one.
So by looking the fixed, sir, how we can identify that it is towards that PL2, sir?
You don't need to identify beta. This is just for your information, not required in making the plot. You just follow the steps. Fix will come automatically.
Okay, okay, sir. Okay.
Sir, we can take any angle bisector also, correct?
Ask again, beta.
Sir, like we have taken at this position bisector of the external angle at C and B. So we
Right.
can take A and B also.
No, beta, no, you cannot take. I told you middle star, middle PL and middle PL के angles को ही external bisector में बनाना है.
Okay, okay, okay.
Sir, I just drew side by side. It is coming.
Great, beta. Excellent. You are fast, man. और बताओ बेटा, और कोई डाउट आ रहे हैं?
कोई डाउट नहीं आ रहा सर.
Sir, just that while making, I found this calculation of external angle is very important because we have to keep the protractor aligned and then calculate the half of the supplement of the angle.
Yeah, that's right, बेटा. आपको बाहर वाला एंगल मेजर करना है, उसे डिवाइड करना है, then you have to make the bisector. Okay, so if you are comfortable, बेटा चलें आगे.
Yes, sir.
Okay, great. So अब बेटा एक और कॉन्सेप्ट आपको मैं करा रहा हूँ. इसी के साथ आगे रिलेटेड कॉन्सेप्ट है. थोड़ा सा और डेप्थ में जाएंगे. तो अपना दिमाग जो है वो एक बार के लिए थोड़ा सा ना यहाँ कंसंट्रेट करना. सो मैं अभी बता रहा हूँ आपको. लिसन टू इट वेरी केयरफुली एंड यू विल अंडरस्टैंड इट. सो पे योर अटेंशन. ये थोड़ा सा ट्रिकी है. इट रेयरली कम्स इन द पेपर, बट इफ इट कम्स देन you will need to apply your brain. So let me explain that to you. Pay attention for about 5-10 minutes. Let's go. Now we move on to the second part of the question. That is finding out the index error. Now, the reason why a cogged hat is formed when we take 3 celestial position lines is due to an error. If there is no error, then all the 3 position lines would intersect at the same point, and there will be no triangle or no cogged hat formed. The triangle or cogged hat is formed only when there is an error in the observation, plotting or calculation of the site. Now we have learned how to resolve this cogged hat in 2 different scenarios: when the bearings are contained within 180 degrees and when the bearings are outside or not contained within 180 degrees. Now in some of the questions, they will also ask you to find out the magnitude of the error which was present in the observation. So how do we find out this error? Now for finding out this error, you have to pick up any of the position lines. Any of the 3 PLs, any one of the 3 PLs can be picked up. For our example, let's pick up the first position line, the red color PL. We can use any of the position lines to find out the error. So in the example, we are using our first position line to find out what the error was. Now we have to draw a line which is parallel to this PL, parallel to the red color PL, and passing from the fix. So we pick up our parallel ruler or sliding ruler or set square, whatever tool you are using, and align it with our first PL, the red color PL, shift it, transfer it to pass from the fix, and then draw a parallel line. Let's draw the parallel line in our plot. You can see the parallel line passing from the fix now. Now this line which we have drawn would be the accurate position line without any error, because this is the PL which is passing from the actual position of the ship. The red color PL had some error in it, and the maroon color PL which we have drawn now passing from the fix is the accurate PL or the exact PL without any error. Now once we have these two parallel lines in our plot, we have to find out the distance between these two parallel lines. The distance between these two parallel lines gives us the error in our site. So you can see this is the distance between the two parallel lines or the two position lines. This distance can be measured off using the scale on which this plot is made. So you can read off what is the distance between these two parallel lines. This gives us the index error. So as you can see in the plot, this distance between the two parallel lines is the index error what we are looking for. This can be done with any of the three position lines. Irrespective of whichever position line you use, you will be getting the same index error. Whether you use the blue color PL, draw a parallel line here and find out the difference, or you use the green color PL, draw a parallel line and find out the difference, the index error will be the same in all the cases. Reason being, this point which we have found, that is our fix, as per geometry, this point is equidistant from all the three sides of the triangle. So whether you find out the distance to the red PL or the blue PL or the green PL, in all the cases, the index error will remain the same. The point where the angle bisectors of a triangle meet is equidistant from all the three sides of the triangle. Same procedure, beta. The same procedure applies even if the fix is outside. So you can go ahead with any other doubts which you may have till now.
So, sir, this index error finding is common for both if bearings are contained within 180 and outside of 180, right?
That's right, beta. Same method for both.
ये एक्यूरेट पीएल ड्रॉ क्यों कर रहे हैं? डायरेक्ट फिक्स्ड डिस्टेंस नहीं ले सकते सर?
बेटा अगर समझ गए हो आप, then you can do that. Please go ahead.
परपेंडिकुलर डिस्टेंस ले लेंगे, हो गया ना सर? इतना ही ना?
Exactly, beta. Sometimes people have problem finding the distance, so that's why I show the simplest method. इसमें गलती नहीं हो सकती है. So if you have understood, great, beta. Go ahead.
बेसिकली सर बस ये सब होने के बाद फिक्स से परपेंडिकुलर डिस्टेंस लेना है फ्रॉम एनी पोजीशन लाइन, दैट विल द एरर.
Exactly.
Sir,
okay.
The answer should be only need to write the index error, no need to write on or off anything.
ओके बेटा, ऑन ऑफ भी बता रहा हूँ अभी, जो बचा खुचा दिमाग है वो भी जरा पास में ले आओ. आई एम नाउ टेलिंग यू हाउ टू फाइंड द ऑन एंड ऑफ. So just pay attention. Another 5 minutes. Let's go to on and off. How to find out whether it is on the arc or off the arc. Say again, beta. Oh,
correct, sir.
Say again, beta.
Sir, ये index error we will take the direct on the scale measurement, correct, sir?
Yes, beta, that's right. As per your scale, you will measure it. So whatever is the magnitude coming, that is the index error.
Okay, sir. Correct. Thank you, sir.
Okay, so let me now tell you on and off. Let's go. Okay, now we have obtained the magnitude of the index error. Now the second thing which we need to find, what is the sign of the index error? We know the index error of the sextant can be on the arc or it can be off the arc. So how do we find out whether this index error was on or off? Let's see. Now to find the sign of the index error, we have to check that when we are moving from the wrong PL, by wrong PL I mean the PL having error, which in our case is the red position line which formed one side of the triangle. So when you are moving from the wrong PL, that is the red PL, to the accurate PL, the accurate PL is the maroon color position line, because it is the PL which is passing exactly from the fix. That's how the position line should be if it is accurately calculated. So when you are moving from the wrong PL, that is the red color PL, to the accurate PL, that is the maroon color PL, you have to see carefully whether you are going away from the body or you are going towards the body. Which body we are talking about? The body, the celestial body using which the PL was calculated. In our case, this celestial body is the red color star, that is star 1. So when we are moving from the red PL towards the accurate PL, that is the maroon color PL passing from the fix, are we going away from star 1 or towards star 1? So you can see this arrow indicates the direction in which we are moving, and it is very much clear that we are moving away from the celestial body, in this case the red color star 1. So in our case here we are moving away from the body. Now moving away from the body, what does that mean? If you are moving away from the body, that means the true zenith distance of the body should increase. Zenith distance is basically the distance or the arc between the zenith of the observer, which is represented by the position, and the celestial body. So if you are moving away from the star, that means the zenith distance of the body should also increase. Now we know that true zenith distance is 90 minus true altitude. So if we want the true zenith distance to increase, then the true altitude should be decreasing. If the true altitude decreases, then 90 minus true altitude, that is the true zenith distance, it is going to increase. And if the true zenith distance increases, this red PL will move towards the maroon color PL and it will become accurate. So we want the true altitude to decrease. Now for true altitude to decrease, the correction which we are applying should be negative. The correction which we are applying to the true altitude should be negative. So this tells us that the index error which we are applying in this case should be negative. Now index error is negative if it is on the arc. So when we are doing altitude correction, if the index error is on the arc, we subtract it. So the index error in this case is on the arc, so we will be subtracting it. When you subtract it, the true altitude would decrease. The value of the true altitude would be lesser. When true altitude decreases, the true zenith distance value would automatically increase. And with the true zenith distance increases, this red color PL, which was having an error, will be corrected, and you will have the accurate PL, which is the maroon color PL passing from the fix. So I'm going to repeat it once. The first thing which you have to see is when you are moving from the wrong PL or the PL having error to the accurate PL or the PL passing from the fix, are you moving away from the body or towards the body? In this case, we are moving away from the body. Moving away from the body, the true zenith distance should increase, which it can do only when the true altitude reduces or decreases. The true altitude would decrease when you have a negative correction, and a negative correction occurs when the index error is on the arc. So now you can go ahead with your doubts, beta. Bolo, beta.
Sir, can you please explain the TZD and true altitude, sir? I have some confusion. From where to measure TZD
बेटा मैं आपको TZD और ट्रू ऑल्टीट्यूड सेलेस्टियल स्फीयर की डायग्राम के साथ एक्सप्लेन करने वाला हूं. इट इज द नेक्स्ट टॉपिक. आई एम गोइंग टू डू दैट इन डिटेल. अभी के लिए आप ये मेथड रिमेंबर कर लो. I will be explaining you what is TZD, what is true altitude, what is rational horizon, what is zenith, सब explain करूंगा.
सर
बोलो बेटा.
याद रखने के लिए हम ये मतलब ये यूज कर सकते हैं कि अच्छा जब भी हम अवे चलेंगे इट विल बी ऑलवेज ऑन द आर्क. ऐसा ये will it stand true in all the conditions?
Yeah, beta, it will stand true if you are moving away from the body on the arc.
Then it will be on the body. When towards the body, it will be off the arc.
That's right.
Okay, sir.
सर इस ट्रायंगल के लिए जब बेरिंग्स विद इन 180 डिग्री है तो उसके लिए हमेशा ही हम मतलब जो हमारा जो फिक्स है वो बॉडी से हमेशा ही मतलब इनसाइड होगी. तो ये जो एरर है हमेशा नेगेटिव होगा ना ये इस ट्रायंगल की स्पेशल ट्रायंगल के.
No. It can be other way also. ये डायग्राम ऐसे तरीके से भी बन सकती है कि ये अवे फ्रॉम द बॉडी की जगह टुवर्ड्स द बॉडी हो जाए. दैट्स पॉसिबल.
ओके सर.
Okay, so you follow the method and then you find out whether it is on or off.
Sir, in this case, TZD is measuring from the ITP, right, sir? That's then only it will increase, right? For TZD to increase, then true altitude should decrease.
TZD is basically the difference between the star and the fix. That is what TZD is. In this diagram, roughly to tell you, to get an idea, TZD is the distance between the star and the fix.
Okay, sir. And there's a true altitude, sir, measuring from same point from the celestial body.
No, beta. No. True altitude doesn't come anywhere in this particular diagram. True altitude is measured between the horizon and the star. So we don't have the horizon here in this diagram. So you cannot visualize and see true altitude in this diagram.
Okay, sir.
लास्ट स्लाइड दिखाना सर एक बार. लास्ट वन.
ओके बेटा, लास्ट वाली स्लाइड दिखा रहा हूं.
सर ये सब स्टेप्स लिखने होंगे एग्जाम में, that moving away from body.
No बेटा, no. These steps were just to explain you the procedure. एक बार आपको ये समझ आ गया, आप डायरेक्टली ये प्लॉट बनाने के बाद सिंपली ये एक एरो बना दो और एरो बना के वहां सीधा आंसर लिख दो, इंडेक्स एरर इज सो मेनी मिनट्स ऑन द आर्क. दैट्स ऑल. यू डोंट नीड टू एक्सप्लेन these steps in the exam. These are just for you to understand.
Okay sir, thank you.
So we can remember this line, right? If going towards, we have to, it will be on the arc, and going away will be off the arc, right?
You can do that beta.
Okay. Regardless the ITP position.
That's right beta. You can do that. So this was the slide beta. This you wanted?
Oh, okay sir, thank you. Next.
Okay beta. So any more doubts beta?
Slide sir next कर दीजिए एक और बार. Next.
Next previous or next forward?
Forward sir, forward. अभी जो चल रही थी.
Okay beta. So we are on the current slide now. So और बताओ बेटा, और डाउट?
Sir, I have some problems sir in this. इसमें तो डिफिकल्ट हो रहा है सर इमेजिन करने के लिए.
वेरी गुड बेटा. डिफिकल्ट हो रहा है ना? डिफिकल्ट हो रहा है ना? मुझे एक बात बताओ, एक ही बात बताओ मुझे बेटा, क्या आप ये रेड और मैरून पीएल अपने प्लॉट में ड्रॉ कर सकते हो?
यस सर.
डिफिकल्ट नहीं है ना? दोनों पीएल आ जाएंगी?
नहीं. सर.
वेरी गुड. ये जो लेफ्ट साइड में 4 पॉइंट दिख रहे हैं बेटा, इनका आप स्क्रीनशॉट लेके रख सकते हो और यू कैन नोट देम इन द नोटबुक.
I have sir already taken the screenshot.
Very good. Just follow them beta. Forget about understanding it. Just follow them.
Sure sir. Okay sir. Yes.
Okay. ये क्वेश्चन बहुत रेयरली पेपर में आता है. कॉग्ड हेड रेजोल्यूशन तो आता रहता है, बट फाइंडिंग इंडेक्स एरर इज वेरी रेयर. इनफैक्ट इट हैज एक्चुअली गॉन आउटसाइड द सिलेबस, बट लोग फिर भी पुराने सवाल डाल देते हैं कभी कभी. दैट्स व्हाई आई डिड इट. सो जस्ट रिमेंबर द मेथड. ये 4 स्टेप याद रखो और क्वेश्चन आए तो उसका सोल्यूशन निकाल दो. नहीं समझ में आया, डोंट वरी अबाउट इट. नो, नॉट एन इशू. इट विल नॉट बी रिक्वायर्ड एनीवेयर एल्स इन द नेविगेशन पार्ट.
यस सर. ओके.
ओके. और बताओ बेटा, नेक्स्ट आउट.
Sir, what about chart work? Chart work में आता है अभी नहीं आता?
I have not seen it for a long time बेटा. पिछले I don't think चार्ट वर्क में पिछले 6-7 साल में ये कभी आया है. I don't remember.
Okay sir, thank you.
Okay beta. So now I'm going to show you a question which is on the calculation of the exact meridian passage time of a star. इसको करने के भी बेटा अलग अलग methods हैं. Not that this is the only method to do it. There are many different methods, but I'm explaining you the method which is given in the book. Calculate the exact meridian passage time of the body. Like for example, in this question, on 12th September 1992, in DR 072 degrees 20 minutes east, the sextant meridian altitude of Aldebaran was 31 degrees 10.2 minutes north of the observer. If index error is 3.2 minutes off the arc and height of eye is 18 meters, find the position lines and also the exact GMT meridian passage. Now the first part of question, we have already seen how the position line is to be calculated. So let us see the solution of the first part. We first go to the almanac on 12th September 1992, and for star Aldebaran we get the SHA as 291 degrees 7.1 minutes, and we obtain the declination of the star as 16 degrees 29.8 minutes north. Now next we correct the altitude of the star. The sextant altitude is given to be 31 degrees 10.2 minutes. Apply the index error, get the observed altitude. Apply the dip correction, get the apparent altitude. We apply the total correction and we get the true altitude of the star, 31 degrees 04.3 minutes. The altitude is to be named as per our naming system. It is mentioned in the question that the star is north of the observer. So altitude is named same as azimuth. That's why we see the altitude named north. The MZD is 90 minus true altitude, which comes out to be 58 degrees 55.7 minutes, and it is named opposite to the azimuth, in this case south. The declination as obtained from the almanac is 16 degrees 29.8 minutes north. So combining the MZD and declination, they are of opposite names. So bigger minus smaller gives us the observed latitude as 42 degrees 25.9 minutes south. So we have obtained the observed latitude, we have obtained the position line, direction of the PL is east-west. Now moving on to the second part of the question, how to find the exact GMT of meridian passage. Now for this, we know that at the time of meridian passage, the LHA of the body is 0 degrees or 360 degrees. At the time of meridian passage, the body is on the observer's meridian. So angle between the meridian of the observer and the meridian of the body is 0. Or you can take it as 360 degrees, both mean the same thing. So LHA star is equal to 0 or 360. LHA star is equal to LHA of Aries plus SHA of star, which is equal to 360 degrees. LHA of Aries is GHA Aries plus longitude east. In this case, the longitude is easterly longitude. So GHA plus easterly longitude will give us the LHA of Aries plus SHA star equal to 360 degrees. Now we know the values of the longitude. It is given to us in the question, 72 degrees 20 minutes east. We know the SHA of the star. We obtained this value from the almanac, 291 degrees 7.1 minutes. Putting these two values here, we get the value of GHA Aries as 356 degrees 32.9 minutes. So with this, we are now aware that at the time of meridian passage of the star, the GHA of Aries was 356 degrees 32.9 minutes. Using this, we can now find out the exact meridian passage time. So any doubts up to here, beta?
सर एक बार LHA की डेफिनेशन बोलेंगे सर.
Okay, beta. LHA is the westerly R angle of the celestial body measured from the observer's meridian. So from the observer meridian, a westerly R angle going up to the celestial meridian of the body is what is LHA. At the time of Marpas, the celestial meridian of the observer and the celestial meridian of the body are same because body is on the observer's meridian. That's why LHA is 0 or 360.
जस्ट फॉर द इंफॉर्मेशन आशीष, ये है ना सोब्रा सर की बुक में पेज नंबर 104 पे भी है सेम चीज जो सर ने समझाई है. अगर वहां से भी देखना चाहो तो वहां से भी देख सकते हो, पेज नंबर 104 पे. ओके यार, थैंक यू.
So okay बेटा, up to here okay. चले आगे.
तो जो ये वाला मेथड है, ये उसमें सन में यूज क्यों नहीं करते अपन?
Say again बेटा.
जो ये मेथड है LHA = 0, जब सन का मेरिडियन पैसेज निकालते हैं तब यूज क्यों नहीं करते सर?
कर सकते हैं बेटा, व्हाई नॉट, वी कैन डू दिस मेथड फॉर सन आल्सो।
ओके, बट सन के लिए तो अपन निकालते हैं ना सर, वो हमारे पास उसको लोकल टाइम मान के फिर उसमें LIT लगाते हैं तो GMT आता है।
बेटा हमें सन के लिए जरूरत नहीं पड़ती ना, क्योंकि सन का हमारे पास जो है वो तो एल्मनैक में वैसे ही दे रखा है, स्टार का नहीं दिया हुआ।
सेम आएगा सर वो टाइम?
या इट विल बी सेम बेटा।
सन के लिए कैसे लगेगा सर, ये इक्वेशन कैसे बनेगी?
बेटा उस केस में LHA सन इक्वल टू 0 और 360 हो जाएगा। LHA sun is equal to GHA sun plus minus longitude. You will get the GHA of sun in that case.
Okay, sir.
Sir, longitude west होगा तो minus होगा ना, GHA is minus long west.
That's right. Longitude east, GHA least. Longitude west, GHA best. Okay, बेटा चलें आगे।
इसमें कंफ्यूजन कभी कभी हो जाता है जब लॉन्गिट्यूड एंड SHA स्टार इज ऑलरेडी ग्रेटर देन 360।
होने तो बेटा कोई बात नहीं है, मैंने आपको बताया हुआ है कि जब भी आप कोई आर एंगल निकालते हो उसकी वैल्यू हमेशा 0 और 360 के बीच में रहती है। अगर वो कभी उससे ऊपर चली जाए या नीचे चली जाए तो आपने उसमें 360 सब्ट्रैक्ट और ऐड करना है। सो यू हैव टू ब्रिंग द वैल्यू विद इन 0 एंड 360 अगेन, उससे सॉल्व हो जाएगा।
ओके सर।
ओके ओके ग्रेट। अब टाइम निकालें बेटा GHA से।
निकालो सर निकालो।
वेरी गुड, चलो आगे। Now we have seen that the meridian passage of the star would occur when the value of GHA Aries is 356 degrees 32.9 minutes. So let's see now how do we find out at what time the value of GHA Aries is equal to 356 32.9. Let's open up the daily page of the almanac. You can see the 12th September 1992 page of the almanac, and if you have a look at the Aries column, the first column which we see, Aries column, it lists the GHA of Aries. Now if you have a look at the values of GHA Aries, let's try to find out within which hours do we have this value of 356 degrees 32.9. And if you have a look here at the table, you will see that our required value of 356 32.9, it comes after 12th day 00 hours. At 00 hours, you see the GHA Aries is 351 degrees 15.0, and at 01 hours it is 006 degrees 17.3 minutes. So our value would lie somewhere in between 00 and 01. Now let's note down the value of GHA Aries at 12th day 00 hours, and this value is 351 degrees 15.0 minutes. The value which we require is 356 32.9. So let's find out the difference, what remains. The difference comes out to be 5 degrees 17.9 minutes. Now this difference is basically because of some minutes and seconds after 00 hours, which will lead to this much of increment in the GHA. So to find out this 5 degrees 17.9 value corresponds to which minute and second, we will have to now go to the increment table. So let's have a look at the increment table. Now when you enter into the increment table, the table starts from 00 minutes, and you have a look under the Aries column. You will see that the increment value of Aries keeps on increasing. Now we have to go to the value 5 degrees 17.9 minutes. So as you see 0 minutes, 1, 2, 3, 4, you will see the value will keep on increasing. And when you reach under 21 minutes, if you look at the Aries column, then you will see that this value of 5 degrees 17.9 minutes, it comes at this particular place. This is where the value of 5 degrees 17.9 minutes is, and this refers to 08 seconds. So the increment of 5 degrees 17.9 corresponds to 21 minutes and 8 seconds. So this gives us the exact time when this GHA Aries would occur, and that time is 12th day 00 hours 21 minutes and 8 seconds. So this is the exact GMT of the meridian passage of Aldebaran on 12th September 1992. So go ahead with your doubts, beta.
All clear, sir.
Great, beta. Excellent. So shall we close this? Close. Bolo, bolo, beta, bolo. Question number 9. ठीक है बेटा, मैं अभी ओपन करता हूँ. So on question number 9. बताओ बेटा डाउट. बेटा आप अपना मेथड बताओ मुझे. Yeah, please do that. Otherwise you can speak, no issues. होल्ड ऑन बेटा, होल्ड, रुक जाओ 1 मिनट. जो आपने ये LIT लगाया, ये किस लॉन्जिट्यूड के लिए लगाया बेटा? विच लॉन्जिट्यूड? इज इट द मॉर्निंग लॉन्जिट्यूड? नहीं बेटा, यहाँ गड़बड़ है. अगर आपको ये मेथड यूज करना है तो आपको पहले 1200 का लॉन्जिट्यूड निकालना पड़ेगा बेटा. ओके. The time is given as 8:50. You consider that Marpas is happening at 1200 hours. Okay, this is the estimation. So you find the longitude for 1200 and you apply the LIT using that longitude बेटा. क्योंकि ये जो लॉन्जिट्यूड आप लगा रहे हो ये तो सुबह का है, मॉर्निंग साइड का है, और जो मरपास टाइम है, मरपास ऑब्जर्वेशन है, वो तो मरपास के टाइम पे होगा ना. सो दैट वुड अकर अराउंड 1200 आवर्स. ओके. ओके, इसमें बस एक ही इशू है बेटा. आपका मेथड सही है, बस एक ही इशू है. जब भी कभी आप टाइम डिफरेंस निकालते हो ना, यू कैन नॉट कंपेयर LMT विद LMT. यू हैव टू कंपेयर GMT विद GMT. तो आप जो आपकी मरपास पोजीशन है उसका LMT मत निकालो, उसका GMT निकालो बेटा. मॉर्निंग का GMT आपके पास है, देन यू कैन कंपेयर. दिस इज ए concept. You cannot compare LMT with LMT to get the voyage duration. ओके, सो ये वाला स्टेप मत करो, आप जीएमटी टू जीएमटी कंपेयर करके निकाल लो, दैट वुड बी करेक्ट, राइट बेटा? ओके, मैं आपको एक्सप्लेन भी कर देता हूं कि एलएमटी टू एलएमटी क्यों हम लोग कंपेयर नहीं कर सकते हैं. Let's assume that you are on a let's assume you are on a flight from let us say न्यू दिल्ली टू कराची, करेक्ट? अब मान लेते हैं कि ये फ्लाइट आधे घंटे की है. जब आपने यहाँ से डिपार्ट किया तो यू डिपार्टेड एट 1000 आवर्स, 10 बजे आपने डिपार्ट किया. जब आप पहुंचे कराची में तो कराची का लोकल टाइम आधे घंटे बाद इट विल बी 1000 आवर्स. ओके, बिकॉज हमारा पाकिस्तान का आधे घंटे का डिफरेंस है. So if you compare LMT with LMT, your voyage duration is 0. Right, beta? Okay. So ship पे इतना फर्क नहीं पड़ता है because vessel speed is very less, but this is a principal concept that we never compare LMT with LMT. इसको GMT to GMT कर लो, आपका मेथड भी सही है. Right. That's right. Okay. I'll tell you बेटा. आप इन दोनों में से कोई भी मेथड यूज कर सकते हो. मैंने देखा है कि कई बच्चों को 1200 पे एस्टिमेटेड पोजीशन लेने वाले मेथड में डाउट होता है, इसलिए मैंने ये वाला मेथड यहाँ शो किया हुआ है. अदरवाइज ये दोनों मेथड करेक्ट हैं. इन दोनों में से कोई भी मेथड आप यूज कर सकते हो, दोनों एप्लीकेबल हैं बेटा. यू विल द सोल्यूशन विल बी राइट इन बोथ द केसेस. सो विच एवर यू आर कंफर्टेबल विद, आप वो वाला मेथड यूज करो. परफेक्टली ऑल राइट बेटा, कोई इशू नहीं है, इसमें डिफरेंस आ सकता है. जो हम ये कंप्यूटेड एल्टीट्यूड निकाल रहे हैं ये अप्रॉक्सीमेट ही होता है. और ये जो आपका टाइम का डिफरेंस आया है 5-6 मिनट, जब आप डेक्लिनेशन निकालोगे तो ये डिफरेंस 0 पे रिड्यूस हो जाएगा. मैक्सिमम इट वुड बी 0.1. 5-6 मिनट में सन की डेक्लिनेशन 0.1 से ज़्यादा चेंज नहीं होगी. सो दैट्स परफेक्टली इन ऑर्डर, नो इश्यूज.
आशीष, जो मैंने फर्स्ट मेथड सोल्व किया ना वो रॉन्ग इसलिए क्योंकि मैंने उसमें जो एलआईटी निकाला ना वो मैंने मॉर्निंग वाला लगाया हुआ है ऑब्जर्व लॉन्ग.
हाँ बेटा, वो नहीं कर सकते हैं क्योंकि टाइम हमारे पास का है और लॉन्जिट्यूड हम सुबह का यूज
तो
कर
सर
रहे हैं.
मैंने
सो
एलएमटी मेरे पास एलएमनेक्स से लेके और एलआईटी मॉर्निंग लॉन्ग लगा के जीएमटी मेरे पास निकाला, उसमें जोन टाइम निकाल के सिप मीन टाइम निकाला सर, मेरे पास टाइम निकाला.
हाँ बेटा, वो
और
मत
फिर
करो
मैंने
आप.
स्ट्रेट हुए मैंने
LIT
832 से सर सीधा उतने का रन लगा दिया, लेकिन सर उसमें वो लॉन्ग मैंने मॉर्निंग वाला लिया, गलत हो गया सर फिर.
हाँ दैट्स राइट बेटा, टेक द
सेकंड मेथड जो है वो मैंने सर वो लिया है,
1200.
पहले मैं 8:30 से 12 बजे तक गया फिर वापस बैकरन लगाया, वो किया सर सेकंड वाला मेथड.
यस, यू कैन डू दैट बेटा. बेटा आपको दोनों में से जो कन्वीनियंट लगे, जिसमें आपको कोई कंफ्यूजन ना हो, आप वो मेथड यूज करो. बिकॉज व्हाट मैटर्स, मेथड तो दोनों सही हैं, व्हाट मैटर्स इन द एग्जाम्स इज दैट यू विल बी अंडर प्रेशर. सो विच मेथड लुक्स मोर क्लियर टू यू, कन्वीनियंट टू यू, यूज दैट.
एक्सक्यूज मी सर.
बोलो बेटा.
सर ये क्वेश्चन नंबर 3 है ना, तो उसमें सर हम लोग, हाँ कुछ,
लेट्स गो टू नंबर 3 बेटा. ओके हाँ बताओ बेटा, नंबर 3 पे आ गए हम.
क्वेश्चन नंबर 3 में सर डीआर लॉन्ग नहीं दिया हुआ, तो पहले हम लोग पी निकालें। पी निकालने के बाद हमें एलएचए पता चला सर, तो बिफोर द मेरिडियन मरपास वो क्या प्रैक्टिकल नेविगेशन में लिखा है ना सर, एलएचए इक्वल्स टू 360 माइनस पी बिफोर मरपास, इफ बिफोर मरपास। तो इस क्वेश्चन में सर हम लोग 2 एलएचए लिए हैं, 2 ऑब्जर्व्ड लॉन्ग से टाइम कंपेयर किए, वो जरूरी है क्या सर?
एक मिनट बेटा।
वो क्या है ना सर, वो एक रात का टाइम है तो रात को सन दिखेगा ही नहीं, तो वो टाइम ऐसे कैंसिल हो जाएगा इसमें।
नहीं, रात का टाइम तो शायद नहीं है, दोपहर का ही है। एक है आफ्टर मरपास, एक है बिफोर मरपास।
ओके, एक मिनट बेटा। इस क्वेश्चन में हमें ऑब्जर्व लॉन्ग निकालना है विदाउट वर्किंग आउट द साइट, राइट?
सॉरी सर, क्वेश्चन नंबर 3 है, 3
नंबर 3।
यही
वाला क्वेश्चन मैं देख रहा हूँ बेटा। इसमें एक तो इंटरसेप्ट निकालना है, राइट? एक मिनट, नंबर 3, लेट मी सी। हाँ बेटा, ये क्वेश्चन नंबर 3 है ना, ये वाला?
रेस्ट ऑफ द मेरिडियन।
दिस वन यू आर आस्किंग ना?
एक मिनट सर, नहीं वो मैं नहीं पूछना चाह रहा हूँ, एक सेकंड सर।
यही है सर।
6 सर, 6
यही है सर, नंबर 3।
हाँ बेटा, पहले नंबर 3 वाला निपटा देते हैं, फिर चलते हैं दूसरे पे। बताओ बेटा, नंबर 3 के डाउट बताओ।
सर मैं क्वेश्चन नंबर गलत कॉल आउट कर दिया, नंबर 3 में नहीं सर।
जी बोलो जी, विदाउट वर्किंग आउट द साइट अगेन, आपका डाउट क्या है बेटा? अभी बता रहा हूँ, बस मैं समझ गया। होल्ड ऑन। ये देखो बेटा, आपने इंटरसेप्ट निकाल लिया। अब आपको ऑब्जर्व लॉन्जिट्यूड चाहिए, पर आपको कैलकुलेट नहीं करना। बिना कैलकुलेशन के ऑब्जर्व लॉन्ग कैसे आएगा, ये पूछ रहा है सवाल। और हमने करना क्या है, इंटरसेप्ट को प्लॉट करना है। ये इंटरसेप्ट को हमने प्लॉट किया, पीएल को ड्रॉ करना है। जिस पॉइंट पे पीएल डीआर लैट को कट कर रही है, उसे बाय प्लॉटिंग हमने निकाल लेना है। ओके, या कोई ट्रिग्नोमेट्री लगाना चाहे वो भी लगा सकता है। इससे निकालना है, कॉस पी के फॉर्मूले से नहीं निकालना है, ये इसका मतलब है। That's right बेटा, that's right. Clear now?
सर एक्चुअली मेरा डाउट ना क्वेश्चन नंबर 6 था, नंबर 3 में गलती से बोल दिया।
नो प्रॉब्लम बेटा, अब चलते हैं 6 पे चलते हैं, कोई बात नहीं, लेट अस गो। ओके, ये हम आ गए बेटा नंबर 6 पे। ये रहा इसका प्लॉट। लेट मी सी नंबर 6 वंस। हाँ बेटा, डाउट बताओ बेटा।
हाँ सर, इसमें ना डीआर लॉन्ग नहीं दिया हुआ सर, तो हम लोग अप्रोक्स एलएचए निकाल के वो तो नहीं कर सकते, इसमें हमें खुद से पता लगाना होगा। तो इस क्वेश्चन में सर सॉल्यूशन में क्या किया हुआ है कि 2 एलएचए लिए हैं, P इक्वल्स टू LHA एंड सॉरी LHA इक्वल्स टू P एंड LHA इक्वल्स टू 360 माइनस P। 2 LHA से 2 ऑब्जर्व्ड लॉन्ग निकाला है, उसके बाद दोनों LIT लगा के सर वापस वो लोग LMT निकाले हैं। तो ये करना जरूरी है कि सर, मैं बोल रहा हूँ ये बिफोर मरपास है फर्स्ट वाला साइट, तो हम लोग बोल सकते हैं ना LHA विल बी 360 माइनस P और डायरेक्ट गो अहेड करे सर। थोड़ा और नीचे,
जस्ट अ मिनट।
हाँ यहाँ पे
इसमें लिखा हुआ है AM, इट्स ऑलरेडी मेंशन्ड एज AM and it is a sun site, so sun is east of you, so when P comes like this, LHA बिल्कुल सही है बेटा, आपको दूसरा LHA निकालने की जरूरत नहीं है, आप सीधा LHA 315 ले सकते हो।
हाँ वही पूछना चाहता, तो डायरेक्ट LHA इक्वल्स टू 360 माइनस P, उसमें कमेंट में लिख सकते सर बिकॉज बिफोर मरपास करके।
बिल्कुल सही है बेटा, you are right. This is a sun site and it is mentioned in the question, it is AM, so sun is east of you. जब भी sun हमारे ईस्ट में होता है, P is equal to 360 minus LHA.
ओके सर, ठीक है सर, थैंक यू।
Perfect, that's right.
एक जो इंटरसेप्ट को अपन शिफ्ट करते हैं तो एक तो डीआर से करते हैं, एक आईटीपी से करते हैं सर।
तो क्वेश्चन में दिया होता है कि आईटीपी से करना है, डीआर से करना है, बट अगर दिया नहीं है तो फिर कैसे सर आईटीपी वाला करेंगे या डीआर से करेंगे वो?
बेटा कोई क्वेश्चन है ऐसा आपके पास?
अभी सर ग्रुप पे है सर, देखता हूँ मैं, उसमें यही शायद उसमें लिखा हुआ नहीं है, देखता हूँ सर।
एक बार देखो बेटा, मुझे दिखा दो वो क्वेश्चन अगर है तो। मार्क द डीआर पोजीशन। ये मैंने बेटा डीआर पोजीशन मार्क कर दी। 1754 पे हमने एक साइट ली है, इंटरसेप्ट है 5 माइल टूवर्ड्स, एजीमुथ 125। सो लेट्स शो एजीमुथ 125। 5 माइल टूवर्ड्स हमारा इंटरसेप्ट है, तो मैंने अपने प्लॉट के हिसाब से 5 माइल टूवर्ड्स पे ये पीएल बना दी। कैन यू टेल मी ये पीएल किस टाइम की है बेटा?
ये सर 1754 की है सर।
वेरी गुड बेटा। सो मैंने यहाँ पे लिख दिया ये 1754 की पीएल है। जो दूसरी पीएल दे रखी है वो है एजीमुथ 175, इंटरसेप्ट 3 माइल्स अवे। तो एजीमुथ 175 का मैंने बनाया, इंटरसेप्ट 3 माइल्स अवे है, सो अपने स्केल के हिसाब से मैं 3 माइल्स अवे चला गया और ये मेरी सेकेंड पीएल आ गई। ये किस टाइम की है बेटा सेकेंड पीएल?
1812।
वेरी गुड, ये 1812 की पीएल है, मैंने ये टाइम यहाँ पे लिख दिया। अब मैं क्या कर रहा हूँ बेटा, अब मैं एक काम कर रहा हूँ, दोनों पीएल हमारे प्लॉट पे आ गई हैं। मुझे इन दोनों पीएल्स को 1800 पे लेके जाना है, क्योंकि जो पोजीशन मुझे चाहिए वो 1800 की चाहिए। सो मैं इन दोनों को 1800 पे लेके जाऊंगा। लेके जाने के लिए 1754 की पीएल पे मुझे 6 मिनट का अहेड रन लगाना है। शिप इज मूविंग 205 12 नॉट्स। सो 205 की डायरेक्शन में शिप मूव कर रहा है 12 नॉट की स्पीड पे। मैंने आईटीपी पे 6 मिनट के लिए रन लगाया विच इज 1.2 माइल्स 205 की डायरेक्शन में। ये मैंने यहाँ अप्लाई कर दिया ग्रीन कलर का वेक्टर। ये मेरे पास एक पॉइंट आ गया, इस पॉइंट से मैंने एक पैरेलल लाइन ड्रॉ कर दी। इसको मैंने डबल एरो लगा दिए क्योंकि ये ट्रांसफर्ड पीएल है। अब मुझे बता सकते हो बेटा ग्रीन कलर की पीएल किस टाइम की है?
सर 1754 को ट्रांसफर किया है, 1800 का हो गया सर अभी।
1800।
वेरी गुड। सो ये हो गई बेटा 1800 की। लेट मी राइट द टाइम हियर, 1800 की पीएल बन गई है। अब मैं क्या कर रहा हूं, जो मेरी 1812 वाली पीएल है, इस पीएल को मैं 12 मिनट पीछे लेके जा रहा हूं। अगर मुझे पीछे जाना है तो 205 का रेसिप्रोकल कोर्स लगाना पड़ेगा विच इज 025। सो मैंने आईटीपी पे 025 का कोर्स लगाया। 12 मिनट में मेरा रन जो है 12 नॉट की स्पीड से 2.4 माइल्स आएगा। ये मैंने कट किया, राइट। और अब मैंने, लेट अस चेंज द कलर, लेट अस पिक रेड कलर। यहाँ पे इस पॉइंट पे मैंने एक लाइन ड्रॉ कर दी पैरेलल टू माय इनिशियल पीएल। इस पे भी मैंने डबल एरो लगा दिए। ये भी अब ट्रांसफर हो गई है। किस टाइम पे ट्रांसफर हो गई है रेड पीएल बेटा?
1800।
वेरी गुड। ये दोनों पीएल 1800 पे ट्रांसफर हो गई हैं। जिस पॉइंट पे ये इंटरसेक्ट करेंगी वो किस पॉइंट किस टाइम की फिक्स आएगी?
एटीन हंड्रेड क्या आ जाएगी सर?
समझ गया बेटा, मेथड समझ में आ गया?
हाँ जी सर।
वेरी गुड। सो अब जो आंसर में लिखा था वहां पे उसको भूल जाओ, इसका एक स्क्रीनशॉट ले लो, इस तरीके से करो, यू विल गेट द करेक्ट आंसर।
सर कई बार क्वेश्चन में ऐसा होता है कि डीआर बोल एक वो दिया रहेगा सर, डीआर जिससे हमने ऑब्जेक्शन ली है, लेकिन सर साथ में उसका कुछ टाइम कुछ और दे देगा, डीआर का कुछ अटंग बटंग टाइम दे देगा सर।
बेटा क्वेश्चन है तो बता दो।
मैं सर आपको अभी भेज रहा हूँ सर ग्रुप में।
ओके ठीक है बेटा, डाल दो। ओके सो बाकी के डाउट बेटा नेक्स्ट क्लास में ले लें। इट्स ऑलरेडी 8:05 नाउ।
ओके सर, ठीक है सर, जब तक सारे क्वेश्चन सॉल्व भी कर लेंगे।
एग्जैक्टली, डू दैट।
ओके सर।
A vessel in DR position so and so at 1830 hours steering a course of 100 observes the following: 1821 hours this much, 1842 this much. Position in lat was used in calculating the star side. Find the following. Okay, क्या डाउट आ रहा है इसमें बेटा?
सर इसमें वेसल डीआर भी दिया है, वो 830 का दिया है सर, और फिर साइड के लिए अलग डीआर लिया है सर उसने, और फिर पोजीशन चाहिए 1830 का जो वेसल डीआर था सर उसका।
राइट, ओके।
इसको कैसे सर अटेम्प्ट करेंगे?
मैं बताता हूँ। जब भी कभी आपको साइट दे रखी होती है तो आपने हमेशा साइट को प्लॉट करने के लिए उसी डीआर को यूज करना है जो कैलकुलेशन में यूज की गई है, क्योंकि ये जो इंटरसेप्ट आया है ये जिसको आपने कैलकुलेशन में यूज किया है उसके बेसिस पे आया है। सो आप 5130 और 00730 वाली पोजीशन को यूज करोगे इन दोनों इंटरसेप्ट्स को प्लॉट करने के लिए।
ओके सर, फिर तो सेम हो गया सर हमने जो कराया है।
जब आप इनको प्लॉट करोगे जो पीएल आएंगी वो अलग अलग टाइम की आएंगी। टीआर कोई भी हो, आपकी पीएल उसी टाइम की होगी जब साइट ली गई है। सो पहली पीएल 1821 की होगी, दूसरी 1842 की होगी, दोनों को सेम टाइम पे लेके आओ जैसा अभी हमने किया। डू एग्जैक्टली लाइक दैट।
तो सर इसमें जो स्टार्टिंग में दिया 1830 डीआर को कंफ्यूज करने के लिए दिया है सर।
अब बेटा उसका कुछ और पर्पस भी हो सकता है। ओके ओके, पर जहां तक प्लॉटिंग की बात थी वो मैंने आपको क्लियर कर दिया।
ओके सर,
ठीक है बेटा,
ठीक है सर।
राइट।